today's session. I'm Mr. Esmia, and today I'm going to be presenting Power Machines N6 under the topic Steam Generation. On steam generation, we are going to look at the components of the steam plant, heat absorbed by each component, flow of steam, mixture of gases, as well as the heat balance sheet. To take you back to N5, remember on N5, steam generation was introduced there, where the formation of steam was discussed, how steam is formed, how steam is superheated to a dry saturated steam or to superheated steam, and the reason of drying the steam, and where the steam is sent after being dried or superheated. Here on N6, we are going to talk about the following components, which is a preheater, component number 1, which is a preheater. A preheater is a heat exchanger that warms incoming air using hot gases from the boiler. It increases combustion efficiency by supplying preheated air to the combustion chamber. An economizer increases the temperature of the feed water, and by doing that, it reduces fuel consumption and improves boiler efficiency. The third component is an evaporator or a boiler. The heat that is sent by fuel, heat water, and water produces steam. So water is inside the boiler, water is being heated by the heat from the fuel, and it converts it to steam. The fourth component is a superheater. A superheater is a unit that heats saturated steam beyond its boiling point. It produces dry, high-temperature steam for improved turbine efficiency. Let's look at heat absorbed by each component. We were going to start by air preheater. The air preheater will absorb the heat that is coming from the mixture of gases or by the products of the combustion. It absorbs heat there, and it heats the air that is from the atmosphere. And when it heats that air, we use the formula QAP equals to MA TA2 minus TA1, where MA is the mass of air, CA is the specific heat capacity of air, and TA2 is the temperature after the air preheater, and TA1 is the temperature before the air preheater. Or we use this formula, which is QAP equals to mgCg, T in minus T out. This one is the energy that is lost by the flue gases when they pass through the air preheater. Where mg is the mass of the flue gases, Cg is the specific heat capacity of the flue gases, T in is the temperature that enters the preheater, T out is the temperature that leaves the preheater, the temperature of the flue gases. The second element or component is an economizer. The heat absorbed by an economizer is the heat that causes the temperature of water to increase. And this heat absorbed by the economizer is calculated using this formula, QEC or QECO equals to MS into H2 minus H1, where MS is the mass of steam, H2 is the enthalpy after the economizer. It is the enthalpy after the economizer. H1 is the enthalpy before the economizer. Or we use the heat energy that is lost by flue gases when they pass through the economizer. The formula for flue gases, when they pass through the economizer, they lose an energy which is mgCg T in minus T out, where T in is the temperature of the flue gases entering the economizer, and T out is the temperature of the flue gases leaving the economizer. The third element is a superheater. Superheater absorbs energy and heats the steam that is from the boiler or from the evaporator, and it heats the steam above the saturation temperature and causes the steam to be superheated or dry saturated. The formula to calculate the heat energy that is absorbed by the superheater is QSUP equals to MS H4 minus H3, where MS is the mass of steam, H4 is the enthalpy of steam, which is the superheated steam. H3 is the enthalpy of wet steam, and wet steam is the steam that is produced by the evaporator. Remember, on N5, you were taught how to calculate the enthalpy of wet steam, how to calculate the enthalpy of superheated steam. And you were also taught how to read the enthalpy of superheated steam on the steam tables when you are given pressure and temperature. We can also use this formula for the energy that is lost by the flue gases when they pass through the superheater, which is QSUP equals to mgCg T in minus T out, where mg is the mass of flue gases, Cg is the specific heat capacity of flue gases, T in is the temperature of flue gases that enters the superheater, and T out is the temperature of flue gases leaving the superheater. Another element that I want us to look at is an evaporator. Evaporator will absorb energy that is direct from the combustion of fuel. When the energy produced by the combustion of fuel, the flue gases passes through the evaporator, they are going to lose the energy, and the evaporator is going to gain the energy, or is going to absorb the energy. Now, the energy that will be absorbed by the evaporator will be Ms into H3 minus H2, where H3 is the enthalpy of steam that is produced by the evaporator. H2 is the enthalpy of steam, or is the enthalpy of liquid that is entering the evaporator. So H3 is the enthalpy of steam that is leaving the evaporator, which is a wet steam. H2 is the enthalpy of liquid entering the evaporator, and Ms is the mass of steam. Or we can use this formula, which is the formula of the heat that is lost by the flue gases when they pass through the evaporator, mg times Cg into T in minus T out, where T in is the temperature of the flue gases entering the evaporator, and T out is the temperature of the flue gases leaving the evaporator. And we have the energy that is supplied by fuel the energy that is supplied by fuel, which is QF equals to MF times CV. Let's talk about the flow of steam, how steam flows, and how flue gases move from the fuel, from the burning of fuel or from the combustion chamber to the chimney. We are going to start by the flow of steam. Steam, it starts by water that enters the economizer, water from the water pump or from the feed water pump to the economizer, and the economizer increases the temperature of water, and that water is sent to the evaporator. The evaporator will boil water, and when water is boiled, steam is going to be produced. When steam is produced, steam will be produced as a wet steam, and that wet steam will be sent to the superheaters, and the superheaters will heat the steam above the saturation temperature, and steam will be sent to the turbine. So that is the flow of steam. But what causes the economizer to increase the temperature of water? Let us look at the flow of air. Air flows from atmosphere. Air flows from atmosphere as TA1. It enters the air preheater. It leaves the air preheater as TA2, which is more than TA1. And this TA2 enters the combustion chamber. That is where fuel is going to be combusted. And from the combustion chamber, flue gases are produced. And these flue gases are the ones that are going to heat up the evaporator, and the evaporator will produce steam. And the flue gases, they pass through the evaporator, they lose energy. That means the temperature of the flue gases that is entering the evaporator will be less than the temperature of the flue gases leaving the evaporator. They leave the evaporator, they pass through the superheater. Again, they enter the superheater at high temperature and they leave the superheater at low temperature. And it is the flow, or it is the heat of flue gases that causes the superheater to heat the steam that is produced by the evaporator. When they pass the superheater, they flow through the economizer, and there is energy that is absorbed by the economizer from the flue gases, and it is that energy that causes the economizer to increase the temperature of water to T2, from T1 to T2, or the enthalpy from H1 to H2. So when the flue gases move through the economizer, the flue gases move through the air preheater, or passes through the air preheater, and causes the air preheater also to increase the temperature of air from the atmosphere to TA2. And after the air preheat, and then the flue gases exit through the chimney. So that means air preheater is the last component that the flue gases are going to pass through when they are exiting. So that is the flow of steam. What is the mixture of gases? The mixture of gases is the byproducts of burning fuel in the combustion chamber that are produced. So when the burning of fuel is taking place in the combustion chamber, the byproducts that are produced there are called flue gases. It can be in terms of moisture or moisture content, or when moisture is excluded, we call those flue gases dry flue gases. So when moisture is there, we call them wet flue gases. Now that we have seen how the steam generation works and how the steam flows, our next lesson will be the actual calculation on this module. Thank you.